Hello friends and welcome to my channel. On today we start a solid state. We start a series of audio books in this channel. So please subscribe us, like, share and comment. So solid state. Chapter 1, solid state. Can you recall what are the three most common states of matter? How does a solid state differ from the other two states? There are two questions. Then 1.1 Introduction. As studied earlier, the solid state of matter is characterized by strong interparticle forces of attraction. As a result, most solid have definite shape and volume which change only slightly with the change in temperature and pressure. The smallest constituent particle of various solid are atoms, ions or molecules. All the such smallest constituent particles of atoms will be as referred to as particles in the chapter. 1.2 Types of solids. There are two types of solid, namely crystalline solid and amorphous solid. 1.2.1 Crystalline solids. Study of many crystalline solid indicate that they possess the following characteristic properties. First, there is a regularity and periodicity in the arrangement of constituent particle in the crystalline solid. The ordered arrangement of particles extend over a long range. Second, crystalline solid have a sharp melting point, that is, they melt at a definite temperature. Third, all crystalline substances except those having cubic structure are anisotropic. In other words, their properties like refractive index, thermal and electrical conductivity, etc., are different in different direction. Ice, salt such as NaCl, metal such as sodium, gold, copper and materials such as diamond, graphite, ceramics and other examples of the crystalline solid. 1.2.2 Amorphous solid. The particles of a solid liquid are in constant motion. The stop action photograph of a liquid describe the amorphous state. In fact, they are supercooled liquids. Amorphous solids have the following characteristics. First, the constituent particles in amorphous solid are randomly arranged. The particles do not have long range ordered structure, but they do have a short range order. Second, amorphous solid do not have sharp melting points. They melt gradually over a temperature interval. On heating, amorphous solid gradually and continuously soften and start to flow. These solids are isotropic. In other words, their properties such as refractive index, conductivity and are all independent of the direction of measurement. They exhibit the same magnitude for any property in even direction. Glass, plastic, rubber, tar, and metallic glass, metalloid alloy are the few examples of amorphous solid. 1.2.3 Isomorphism and polymorphism. Similarly or dissimilarity, similarity or dissimilarity crystal structure of different solid is described as isomorphism or polymorphism. First, isomorphism. Two or more substances having the same crystal structure are said to be isomorphous. In this substance, the chemical composition has the same atomic ratio. For example, NaF and MgO, NaNO3 and CaCO3 are isomorphous pairs and have the same atomic ratios 1:1 and 1:1:3 respectively of a constant atom. Polymorphism, a single substance that exists in two or more forms or crystalline structure is said to be polymorphous. Polymorphs of a substance are formed under different conditions. For example, calcite and aragonite are two forms of calcium carbonate. Alpha quartz, beta quartz are crystallite are three of the several forms of silica. Polymorphism occurring in elements is called allotropy. For example, three polymorphic allotropic forms of carbon and diamond, graphite, and fullerene. 1.3 Classification of crystalline solids. Crystalline solids are further classified into four categories: ionic solid, covalent network solid, molecular solid, and metallic solids. Ionic crystal. Ionic crystals have the following characteristics. The constituent particle of an ionic crystal are charged ion. The cation and anion may differ in size. Each ion of the given size sign of charge is bonded to ion of opposite charge around it by Coulomb's force. In other words, the particles of ionic crystals are held by electrostatic force of attraction between oppositely charged ions. Third, ionic crystals are hard and brittle. They have high melting points. Fourth, these are non-conductor of electricity in solid state. However, they are good conductors when melted or dissolved in water. For example, NaCl, K2SO4, CaF2, KCl are ionic crystals. Covalent network crystal. Characteristics of covalent network crystals are as follows. First, the constituent particles in covalent network solid are atoms. The atoms in these crystals are linked by a continuous system of covalent bonds. The result in a rigid three-dimensional network that forms a giant molecule, the entire crystal in a single molecule. As a result of rigid and strong bonded structure, covalent network crystals are very hard. In fact, they are the hardest and most incompressible of all the materials. These crystals have high melting and boiling points. The electrons are localized in covalent bond and hence are not mobile. As a result, covalent solids are a poor conductor of heat and electricity. For example, diamond, quartz, SiO2, boron, nitride, carborandom are covalent network crystals. 1.3.3 Molecular crystals. Substances such as Cl2, CH4, H2, CO2, O2 on solidification give molecular crystal. Crystalline organic compound are also molecular solids. Point 1. The constituent particles of molecule molecular solid are molecules or unbounded single atoms of the substance. The bond within Second point, the bond within the molecule are covalent. The molecules are held together by various intermolecular forces of attraction. For example, weak dipole-dipole interaction in polar molecules such as solid HCl, H2O, SO2, which poses permanent dipole moment. B. Very weak dispersion or London forces. In non-polar molecules such as a solid CH4, H2, these forces are also involved in monoatomic solid like argon, neon. These substances are usually gases at room temperature. Intermolecular hydrogen bonds. In solid such as H2O, NH2, HF, and so forth. Third, because of weak intermolecular attractive force, molecular solids are usually soft substances with low melting point. The solids are poor electrical conductors and are good insulator. Metallic crystals. These are crystalline solid formed by atoms of the same metallic elements held together by a metallic bond. Metallic bond. In a solid metal, the valence electrons are delocalized over the entire crystal, leaving behind a positively charged metal ion. Therefore, metallic crystals are often described as an array of positive ion immersed in a sea of mobile electron. The attractive interaction between cation and mobile electrons constitute the metallic bonds. Metallic crystals have the following properties. First, metal are malleable, that is, they can be hammered into thin sheet. Second point, metals are ductile, that is, can be they can be drawn into wires. And third point, metal have good electrical and thermal conductivity. Example, metals such as Na, K, Ca, Li, Fe, Au, Ag, Co, etc. These properties of different types of crystalline solid are summarized in table 1.1. So the second part we discuss the whole chapter. So thanks for watching. Please like, share and subscribe to my channel for this full. Want to watch this full series? Then please subscribe us. Thank you.